Hey guys, we're going to go ahead and get started with chapter 12, talking about a little bit of geometry. We will come back to chapter 11, the test. If you have any questions, we can go over some of that once you are done turning in your test corrections. So let's go ahead and get started in chapter 12. Geometry. It is the study of, we're going to go over all of these terms in just a moment, points, lines, planes, and the figures that they form. So let's first start off with a point. This is just a specific location in space. We represent it with this dot right here. The one example I can think of is if you have, maybe we've talked about this before, but if you have a needle, think about the tip of a needle. It's very small. That's almost, a point is, it's just a location in space. It's a very, very small location, but it is called a point. So if they say name the point, you would say point A, or you could use this little dot right here and then the capital letter. Next, we're talking about a line. We've been graphing lines a lot in this last chapter. Remember, a line is made up of at least 2 points, but we also talked about that it's made up of an infinite number of points, which means, therefore, it extends infinitely in opposite directions. So this figure is called line BC. We represent a line. The symbol is a line with 2 arrows on the ends of the lines. But yes, this line, it's made up of an infinite amount of points and it's going to extend infinitely. We couldn't draw an infinite line, but this line does not stop. It keeps going out in the right direction and into the left direction. A plane. This is a flat surface and it's going in all directions. Think of a piece of paper. If you were to hold a piece of paper in your hand, think of that piece of paper as a plane, and it's going to extend in that direction, that direction, that direction. That is going to extend in all directions. That is a plane. We represent it by 3 capital letters. This is a line segment, or just a segment. As you can see, we've got endpoints on the end. So this is different from a line because a line extends infinitely in both directions. A segment is going to be cut off. We're going to have a definite length here. So it's again made up of all the points in between G and H. We represent a line segment with the 2 letters with 2 points, but we just have a bar over the top of it. And we could also say segment HG. Let me get my pen up here so I can write if I need to. But we could also call this segment HG instead of doing GH. This is called a ray. It is like a segment and a line put together. So we have an endpoint, we have a starting point, but then it's going to extend into one direction infinitely. This is called ray, JK. JK with the symbol, with the ray symbol going in the direction of which side goes infinitely. So I could not say JK, or, trying to get the hang of this. I could not say that this is ray KJ. Why? Because the K point is going in the infinite direction. K is not the end point. So this will not work for a ray. It will work for a segment, it will work for a line, and it will work for a plane. You can rearrange the letters. We're going to look at an example here in just a second. Oh, right now. All right, name all the possible points, lines, planes, segments, etc. in this figure. So let's talk about the points. First of all, I've got 3 points, X, Y, and Z. Now, there are an infinite number of points on all of these lines here, but the points that they've listed are X, Y, and Z. Lines, I've got line XY, and like I said earlier, you could say line YX. Line XY and line YX are the same exact line. Line YZ, again, line ZY, you can rearrange these two letters, and line XZ. And notice how I'm saying these things. I'm saying line XY, line YZ, line XZ. How do I know that it's a line? Well, I look at the symbol above it, which tells me what kind of geometric figure it is. And then lastly, plane XYZ. Again, I could say plane YZX, and I look and see that I have 3 capital letters with the word plane in front of it. Segments. This could also be line segment, or just segment XY, or segment YX, segment YZ, and segment XZ. Again, when I'm asking you in class or over live stream or whatever, you need to say, don't just say XY or YZ, you need to say segment. And then your rays, you've got ray XY, ray YX. Again, these two are not the same. Remember, when we're dealing with rays, whatever your endpoint is, it needs to be the first point. So ray XY and ray YX are not the same rays in this illustration here. Ray YZ and so on and so forth. You have 6 different rays here. So up here again, just clarification, segment XY and segment YX, those are the same exact segments. If you write one and you're listing them all, then you can't rewrite segment YX. That would be the same one. Why don't you do this on your paper? Draw and label the following geometric figures. What is number 1? I'll give you a second to do numbers 1, 2, and 3. For number 1, hopefully you drew a segment. We have 2 endpoints. A and B are the endpoints. Number 2, this is line MN. So I need to draw 2 points, M and N, but I am going to have 2 arrows on the end of my line because they're going to extend infinitely. And then lastly, I should have ray XY. If you wrote ray YX, that would have been incorrect because Y is not your endpoint. Hopefully you didn't make that mistake though. Name a line that passes through A. Well, we've got 2 that go through. Again, if it's just a single capital letter, that is represented as point A. So name a line that passes through point A. And we've got 2, line AB or line BA and line AC. What about a segment with an endpoint of B? Well, we've got segment CB or segment BC and segment AB or segment BA. Name 2 rays with the endpoint of point C. So the endpoint has to be point C. And those are the only 2 answers that would be accepted. Let's talk about angles. Notice, what is an angle made up of? It's made up of 2 rays. But notice their endpoints are common. We've got a common endpoint between these 2 rays. This is called the vertex, and each ray is a side of the angle. Measuring an angle, make sure that when you have your protractor, oh, you know what? Let me double check. Yes, I'm going to have to get y'all a protractor. For right now, though, Ethan, I may need to I may need to get one to you, or unless maybe you have one at home. But Priscilla and Brinley, your siblings in geometry, Kaden and Boogie, they were supposed to pick one up. So use their protractor. If you don't have a protractor, let me know. Here we go. Position the center of the protractor on the vertex of the angle. And I think here's what I'll do with this one. I may just send you a video of how to measure angles, or I will send you a YouTube video of how to measure using a protractor. Let's move on for right now. Let's talk about the different types of angles. This should be review. What kind of angle do we have right here with angle X? Hopefully you said acute because it's less than 90 degrees. This is how we name an angle if we're talking about the measurement. Little m right here represents measurement. So the measurement of angle X is going to be less than 90 degrees. Again, this should be review for you. So this one right here is a 90-degree angle, so it's a right angle. The measurement of angle Y, we can name an angle by 3 points, or if they just give us 1 point, which is what they have right here, we name it using 1 point. The measurement of angle Y is equal to 90 degrees. This one's obtuse because it's greater than 90 degrees, but not quite 180 degrees. An acute angle, hopefully you realize this, but not only is it less than 90 degrees, but it's also greater than 0 degrees. You can't have a 0-degree angle, then you wouldn't have an angle. Anyways, and then lastly, we have a straight angle, which the measurement of angle W must equal 180 degrees. In the previous slide, we talked about angles being named by either 1 point, so they have 1 point here, or we can name them using 3 points, because we couldn't just say, oh, angle A is, because guess what? There are multiple angles in this figure right here. We have angle CAB, we name it by 3 points. We have angle DAB, and we have angle EAB. We also have angle DAC. We also have angle CAE, angle DAE. So make sure that if you're given multiple angles like we are right here, that you can't just say angle A. Which one are you talking about? So let's go to letter A, angle DAE. So we're talking about this angle right here, angle DAE. Let's talk about the measurement of this angle. Well, first off, what kind of angle is angle DAE? It's an acute angle. Acute angles must be less than 90 degrees. So let's talk about reading this on our protractor here. If I've got 130 degrees, is angle DAE 130 degrees? No, it's not. So hopefully that should give you a red flag in your mind that, oh, oops, I am starting from the wrong degree measurement. I need to start from 0 degrees when I measure using a protractor, going 0, 10, 20, 30, 40. Angle DAE is a 50-degree angle. And again, this is how you're going to measure your angles. Point A right here is going to be, on your protractor, you'll either have an open circle where you'll put the dot or the point A over that, or excuse me, you'll put the open circle over this point, or sometimes there will be a little dash right where the vertex should be, right there. And you'll know that's where I need to line up my angle in order to use my protractor to measure it. Let's talk about angle CAE. Now, what kind of angle is CAE? It is an obtuse angle, so it's got to be greater than 90 but less than 180. Again, where are we starting from? We're starting, where's my side angle, starting at 0 degrees, going all the way up to about, let's see, it's in between 120 and 130. Go up here, Here we go. We can find our ones. We know that this angle is not 135. It should be 125 degrees. Again, if I were to look at this and say, oh, angle CAE, that's 55 degrees. Wrong. Make sure you're very careful. Why don't you go ahead and do letter C and letter D. Find the measurements of both of those angles. Angle BAC, now we're starting down here from our 0 point. Hopefully you notice that angle BAC is an acute angle, and that one, sure enough, is 55 degrees. Angle BAE is a straight angle. How many degrees does a straight angle measure? 180 degrees. Name the following angles in the figure. Let's find acute angles. Well, let's see. Angle EFG, is that an acute angle? No, that's a right angle. So that would actually go under letter B. What about this one right here, 35 degrees? Okay, what angle is that? You have to name the angle. Could I say angle E? No, I can't just say angle E because are you talking about angle FEG or angle GEH? Well, we're talking about angle GEH, or you could name it angle HEG. That is one of our acute angles. This is another one of our acute angles, angle EHG. So we've got two acute angles that are listed. Do we have any other acute angles? We do. Did anybody catch angle EGF or angle FGE right here? How do you know that angle FGE is an acute angle? How do you know that angle FEG or angle GEF right here? How do you know that these two angles are acute angles? Does anybody know what the measurement of angle FEG is or the measurement of angle EGF? Doesn't ask us for it, but we can find out. If this one's 120 degrees and this angle is attaching it, this angle right here would be 60 degrees because angle FGH makes a straight angle. A straight angle is 180 degrees, so the two angle measurements that make up the straight angle must add up to 180 degrees. Therefore, if this angle is 90, this one's 60, what would angle GEF be? 30 degrees because there are 180 degrees in a triangle. Hopefully you got all, so technically we've got GEH, we've got GEF, we've got FEH. Oh, I missed that one. Did anybody else get that one? This is an acute angle. 30 plus 35 degrees is 65 degrees. That's angle FEH. I missed that one. And angle H, angle FGE. There are 5 acute angles. How many right angles are there? Just one, angle F. If you would have said angle E, excuse my drawing, if you would have said angle EFG, is that the same as just saying angle F? Yes, it is, because angle F right here is not referring to any other angles like point E up here is. What about all the obtuse angles? Go ahead and find those. Just one. Angle EGH, 120 degrees, is the only obtuse angle. What about the straight angle? Only one of those as well, angle FGH. If the measurement of angle WYZ is 23 degrees, write and solve an equation to find the measurement of XYW. If you take a look over here at our example figure, we know that this angle right here is 23 degrees. We know that the whole measurement of angle XYZ is 57 degrees. How can we find this angle right here, angle XYW? Well, we know that both of these angles added together will be 57 degrees. How can I find angle measurement XWY by itself? Opposite operation is to subtract 23 from both sides. My measurement is 34 degrees. Why don't you classify each of these just out loud real quick? Acute, obtuse, and right. They wanted you to measure them using your protractor. One, I'm not sure if you have access to your protractor yet, and two, it might be a little harder to do it on your screen, but does this look like it could be a 39-degree angle? I hope so. If you were to measure this angle, number one, and get 111 degrees, something is wrong because this should be an acute angle, and so on and so forth for the rest of those examples. Excuse me. How would I find the missing angle measurement in this figure right here? Draw an equation like we did for the previous one. The measurement of angle ABD plus 33 degrees should equal what? 48 degrees. How do I solve for the missing angle measurement? Opposite operation. And what should I get? The measurement of angle ABD should be 15 degrees. Find the missing angle measurement in the following figure now. How would I find angle PQS? Same thing. Both of those angles added together, this angle and this angle right here, will give me the whole entire angle, which says, they tell me, is 136 degrees. Here's my equation. My missing angle is 97 degrees, and we can check that by adding 97 degrees plus 39 degrees. You should get 136 degrees. All right, that is all for now. I will have some example problems up in the next video.